Hey beautiful minds, I am Gurmeet Singh from Physics with Gurmeet. Today, let's do some physics, but before that, watch this video. So, Kittu, what do you think? What force has Singh experienced here? Okay. It seems like Kittu does not want to teach you physics. Okay, no problem. I'm here for you. Let's see. We've got two scenarios here. The first one before cutting the string, and second after cutting the string. We can solve this particular problem by various methods of physics. But I'm going to show you a very basic principle of physics here, which is Newton's laws of motion. Let's talk about the before cutting the string scenario. This problem can be solved by assuming the few things like the string is frictionless, massless, and inextensible, as well as the support is movable in the upward direction and fixed to the downward direction, which is the Singh's hand in the video. Now, in order to solve this problem, we need to find out its equilibrium equation, which tells us that upward force is equals to the downward force in the magnitude. We can see the system where m1 has weighing force in the downward direction m1g and the upward force, which is the balanced force here, as the t. And in the second system, the mass m2 has weighing force in the downward direction m2g and upward force t. By using this system, we can make its free body diagram, and then after we can find out its equilibrium equation. So the free body diagram of this system is in the upward direction is 2 times of t, and the one force is m1g and another one is m2g, which m2 has exerted in this case. So the equilibrium equation here, we've got 2t is equals to m1g plus m2g, which is nothing but t equals to m1g m2g by 2. By using this equilibrium equation, we can easily find out at what force the support is hit the Singh and what was its acceleration. Let's talk about after cutting the rope situation. We can solve this problem too by assuming two more things. The one is, I'm going to assume the mass of the support is uppercase M and both the strings have been cut off simultaneously, due to which this 2t tension is become 0 eventually, and now the equation can be written as 0 equals to this. According to Newton's third law of motion, which tells us that every action has equal and opposite reaction, the same situation has been repeated in our case too. The tensional force by which both the masses were holding off after cutting the string is immediately become 0. So, as per the law, the weighing force exerted by the masses is now become the reason of motion of the support. Here, the tension becomes 0 at the cost of reducing acceleration into the support, and the force exerted on the support is ma equals to m1g plus m2g, and the acceleration is m1g plus m2g by capital M. So the Singh is being hit by this force, and the acceleration in his hands is this. They solved. Okay. Hey, wait a minute. For joining the live classes for class 11th and 12th, you can contact me at the number below and on Instagram ID on this. Cheers.